Hello everyone, Darren here, and welcome to The Farmer Was Replaced. This is a new automation game where a little drone will farm an ever-growing set of tiles so that you can earn resources to improve the drone, make bigger fields, and optimize what you harvest. But it's got a unique twist. You're the one responsible for programming the drone. That's right, this is a programming game, but don't be intimidated, please don't click off just yet. This is an extremely accessible programming game. So much so that I'm putting it on my channel. I was really interested by it. It's completely different to things I play, but I had to show it. It teaches you the complete basics. I believe even if you've never programmed before, you can quite easily pick up a basic understanding with this game, make some progress, just have some fun, and if you apply yourself, maybe you can actually become quite decent at it. So I'm going to talk through some of the early stages of the game and try to summarize how everything works. Hopefully you'll be able to follow along. It's worth mentioning I did go to college for programming, and graduated, but I fell into marketing instead almost straight away. Excuse me, and then did YouTube for many years, so I'm very rusty, and I've been trying to get back into the swing of things lately. And I found this game to be really helpful so far at making the learning process just much more fun. It's far more fun than looking at videos or tutorials about general coding rules and programs, to be actually just playing a game that's kind of teaching you as you go, and, you know, satisfies that sort of automation itch that many of us have. So let's begin. So this is something you can expect a lot from the game. A lot of windows, tutorials, things telling you stuff. Up in the top right, we can always just open info windows to learn stuff about how things work. I'll try to guide you through some of these things, but this stuff is awesome to read. I mean, I know it might be like, oh my god, I don't want to play a game and just read tons of text. It's pretty straightforward, actually. I must say the first window gives you a lot of text, but from then on, it does get more complicated, but it kind of always gives you like, here's a new command you can do, and you can just start straight away. So we could do a flip. Let's do it. So do a flip is a function. Functions need to have parentheses next to them. Normally you're passing arguments into a function for it to do something with that. Maybe if, you know, perhaps certain functions could say do a flip 5, that would mean do it 5 times. I don't know necessarily about how do a flip works, but we're just going to leave it empty so we do it just once. How fun. So this is the drone we're actually in control of. The one that's kind of moving around is actually just following my cursor, I think, for the fun of it. Maybe in the future we do more with it, but I haven't seen that just yet. So this is actually where our resources go, into the piggy bank. So harvest is really the one that's going to be the main thing that we focus on. So we'll do harvest. And that little piece of hay went into our piggy bank, and we have it up in the top left now. Obtained by cutting grass. So we'll get rid of this big window now. Don't worry about it. I'll just focus on our little one tile for now. So harvest. Every time we hit play, we get 1 hay. The second play button means to just execute one line of the code. We've only got one line, so that's all it's going to do, really. Now, we've only got one line, so it just pauses after that. If we hit play again, it'll just end. And then, yeah, starts or stops the execution of the code. So, another thing we could do. Let's go let's say I don't want to click this button every single time, right? Maybe we could just do it like this. And we can see that it executes linearly. It executes straight from the top down to the bottom, one by one. And that's how code works, for those who don't know. So one by one, it just goes through the harvest calls, and then it ends. But that's not the best either. We still have to click this button. Nobody likes clicking buttons. We want to be able to do it automatically. So if we open up the tech tree, we've now earned 20 hay. And the first thing we can get is a loop. Unlocks a simple while loop. So while true, harvest. So it's telling us the new kind of thing that we're unlocking. So we'll just click into that. We get a little documentation about it. You can actually zoom in and out of this as well if it feels like it's too big on your screen. So basically, a while loop, while condition, then loop the body. So the hashtag symbol here, plus, and then whatever you write after it in this sort of gray, is a comment. It's not executed. It's just for us to read as humans. And depending on the language of code, often this is usually 2 forward slashes, like in C or C# or something like that. The language in this game is Python, or it's at least closely resembling the syntax of Python. Syntax is basically the formatting of text. So this is basically like learning Python, but the logic of coding applies to sort of most languages. So what you learn in Python, first of all, Python is extremely ubiquitous, so it's good to learn anyway, if you did care about that. But also, this can be applied to many other languages, just totally fine. You just write things slightly differently. Classically, like in C or C++ or whatever, you'll use brackets or parentheses whenever you have things here. But in Python, you just use like a little semicolon. So while condition, or colon, actually, sorry. While condition, and then loop the body, and we can put stuff in there. So let's test it out. So we'll say while true, and then this is our basic like bracket. So again, just really quickly, if you were to do this in C, you'd write something like this, and then what happens in here is executed. But in Python, it's not done that way. I'm new to Python, so that stuff took me a little while to learn. I actually did learn a little Python when I was in college, and we all hated it at the time. We learned it for like server stuff. Anyway, so while true, harvest, right? That's all we want to do. We could even flip every time we wanted to. So we'll just do this for now. So while true, harvest. So you might be wondering, like, while what's true? What's true? What do you mean, while true? Just means while the true statement stays true. We're never changing it anywhere. We're never saying that this should change, so it's just going to run forever. And we can see we're just making up our little bit of hay up in the top left forever. Pretty easy. Now it's obviously going to get far more complicated than that, but hopefully that explains the concept of this loop. Now this is indented one tab over to let us know that that's kind of been done inside of this. So we'll just pause that for a second or stop it. If we then did do a flip and then harvest again, well, you wouldn't even need to do that actually, that'd be stupid. But you could just do a flip, so this would be a waste of time, but this will show you that we're executing one by one in each thing. You can see it actually flashing to let us know which line is being executed, which is really nice. So it's saying while harvest, do a flip, while harvest, do a flip. Poor little guy, it's going to be tired. Alright, we'll continue letting that get done. So we have 100 hay. So let's open up our tech tree. That still continues on in the background, by the way, which is super nice. So we can unlock some hats if you wanted to customize ourselves. So change hat to hats.gray hat, or purple, or green, or brown. So we've got a little straw hat on at the moment. So what we could do is open up another window. Just leave that going all the time, which is awesome. It basically means that as an automation or idle clicker type of game, we can sort of leave our guy doing his thing while we write new code for him to improve based on how we expand. But just for a little bit of fun, yeah, so we can go change hat, and then we'll change it to, so it's hats dot, so hats would be like the class, I guess, is it? And then a brown hat, a carrot hat, straw hat, tree hat. So we'll do carrot hat, end our parentheses, and then just execute that. So there we go, we've got like a series of carrots around us. There is a cone hat. I can't remember how we get it though, but I guess I haven't unlocked it anymore. But yeah, we'll just go back to straw. It's fine by me. Maybe a blue hat would be nice, would it? Do I have blue? No. Okay, great. We have stuff to unlock then. Anyway, we'll just let this play again. So you'll notice that when we ran that, this one stopped. You do only run one code block at a time. I'm assuming in future you'll be able to call another code block from one. But I don't know yet. Code block's probably not even the right term there. These are most likely like classes, I guess. Anyways, so let's see what's up next. We're up to nearly 200 hay. So this one will allow us to increase the speed of both the drone and the code execution. So in the first information screen, it actually tells us that code is being executed every 1 second, I think, or maybe 0.5 seconds. Just for the sake of this game. Obviously code in real life runs extremely fast, but for the sake of this game it's done in a certain time limit. We're going to increase that now. So, speed upgrade. We've got a little problem on our hands though. He's actually not harvesting anything anymore, the drone. Sorry, I don't want to assume the drone's gender, but I'll just say he from now on, just so we know. So the drone is, yeah, it's not getting anything because the grass is never getting time to get to full growth. It takes 0.5 seconds to grow 100%, but we're harvesting it too fast now. So let's stop this, and then play it again, we get one. Stop it, play it again, we get another one. Can't do that anymore, right? So that doesn't seem right. But we've unlocked an if statement, some basic if statements. So if something is true or false, or some sort of condition, then do something. So let's try that. So while true is still going to be our overall loop, but now we'll say if you can harvest, which is a little check, right? It says use to find out if plants are fully grown. It returns true if there is an entity under the drone that is ready to be harvested, false otherwise. So if can harvest, then harvest. Just like that. You actually don't need these brackets thinking about it in Python, and then we put our colon. So now it's only going to harvest when the grass is fully grown. Straight up, super simple. Our first little if statement. Alright, let's see what else we can get. So now we need wood, and there's many more resources in this game, but now we need wood in order to increase our speed again. So you actually see that you can do this 5 times. The next one over here is 300 grasses needed to increase the yield. Next one down here is to expand the farm and unlock movement. And then there's also to plant bushes. So let's get everything. We'll do expanding first. This resets the farm, but actually kept us going anyway, which is fine. So your farm is grown. The space is not much use if you can't move the drone though, so you can go move north, east, south, or west. So yeah, so let's begin. So what we can actually do, like I said, is open up a new window and just copy and paste this in over here if you wanted to, and we'll just call this new main. And this will be the code that we're planning on executing once we're ready. So this way we can keep going in the background while we're figuring out what to do next. So every time you harvest, once you're done harvesting, we want you to move up to the next tile, yeah? So then we'll just say, if you can harvest, then harvest, but then also move. And we'll just move, in fact, we'll move south. Because it wraps around. So if we move south, there's nowhere to go. It'll go to the very top and then move down one each time. So let's go stop that and play. And there you go. Totally simple, totally easy. No problems. We can delete this old one now. And we can just call this main again if you want. Although you have to stop it actually to do that, I guess. Yeah. Cool. So super simple. Nice, simple, just 3 tiles. Not too difficult. Open the tech tree. So next we'll get the increase the yield of grass. So we're going to get double the amount every time we pull grass. So that should allow us to gain a bit quicker now. Next up, we could get the bushes. So bushes are needed to get wood. So plant entities.bush. Awesome. So grass is nice because it grows automatically. All other plants have to be planted with the plant function. The only plant you can plant right now is a bush. You can pass the type of plant you want to plant to the function like this. Plant, entity, or bush. This will plant the bush. Call clear to reset the farm to all grass and reset the drone position. So one thing I could do is create a new function and call it, or I guess class. Class doesn't feel right either. I'll just call it code block. We'll call this to clear. And then do that, right? So if I just stop this, click this, boom. So this is tile 0, 0. This one is tile 0, 1 and 0, 2. So we're going up that way with the y-axis. So I'm going to minimize this. And then if we ever need to clear, we just click this button. So that'll be super simple in the future. Let's just continue letting this do its thing. So we want to start planting some... We've got enough hay, I think, for a little while. What else could we get? Yeah, that's it, right? So just wanted to make sure. Cool. All right, so we'll now plant just trees or bushes here instead. So I'll copy this, get our new code block. While true, can harvest, harvest. So the interesting thing, well, I guess I'll just show you first. So we'll write in here, plant entities.bush. Okay, so after we harvest, plant a bush. So stop that right now. Alright, but why isn't it moving? Because we didn't add the move. So now it's just going to sit above 1, waiting. So let's add the move back in. Now it's going to do it to each one. It's quite slow though to have to wait for each one to grow, but I guess that's just the way it is. Now at least we're making wood, so simple enough. Now you'll notice the hay comes in really quickly after we harvest. That's because once we harvest, it resets it to grass, just automatically when it's bushes. But we're planting a bush right on top of it, so it resets it back to a bush. That's just the way bushes work. Other things won't work that way, we'll see in future. Alright, so just going to copy and paste that in here and just leave it running on the main. And we'll just reset this as our little temporary function. Code block. Alright, so we're up to 30 wood. Excellent. So next up, we can now expand the farm so that we have a 3x3 grid. So second expansion. So now a nice 3x3 grid, but we're still doing the same thing. Your farm is expanded again. Now the tiles are no longer in a nice row, so you need to find a way to traverse a square grid. This is basically what the game becomes about. It's this. You can almost think of this as an array, a 2D array, and we basically are going to be managing that over a very large scale later on. For the purposes of this video, I probably won't go too big. Maybe we'll just get to like 6 or 9 or whatever, but then we'll leave it there. So we've just unlocked the for loop. So a for loop is more of a conditional loop that increments with a certain value. So it gets a bit more complicated here, right? You can read about the for loop, and I had to read this for a while because in Python it is a little bit different than in C# or C++. So it kind of tells us about ranges and how you can kind of navigate them. So there's still a little bit for me to learn in terms of just how Python handles it, but we can just implement it how I know it anyway, and we should be good. So let's just copy this. We'll just let this guy continue doing its thing. So if we can harvest it, and then plant bush. So we're just planting bushes here, and then we're moving south. But now we're going to introduce the for loop. So we'll say for I, which is our increment, in range, what do we have? 3? So we've got 3 by 3. And then we'll just move that across, and move all this across. And we need a colon. So for every, yeah, so harvest. So what we'll need to do now is then push this back. So moving south, we're starting here actually. So now I'm going to say you want to move east and then move north. Okay, so it'll make sense in just one sec. So we'll say move east and then move south, north. So everything's remaining the same. Just pause this guy now. And actually, if I could, maybe we'll say move south. Just start at the bottom again. Well, actually, I know. We'll just clear it. There you go. Just clear everything. Great. So now we're going to try this. So while true, that's our basic loop for the range of 3. So 3 times over, and then it'll loop again. So this runs just 3 times and then it resets. If can harvest, plant bushes. So what I expect to see is that we're planting bushes everywhere. Let's see. Ah, so I made a mistake. Classic. So let's see what I've done wrong. I'm going to go through this. So if we can harvest, plant the bush, and then move east. So I would have thought we were moving east. Oh, yeah, my bad. Here's what went wrong. This should be out here. There we go. So, again, not having parentheses has tripped me up a little bit. Don't worry about that, by the way. So basically, where the indent starts and ends is kind of when the loop, or the range of this is going to happen. The loop is, God, I can't speak. Hopefully you get the idea, though. So for every I in range 3, every time this loops, we add 1 to this, right? So once this for, I'm going to just pause this for a second. So we do this line, and then we go into here, and then we do these 3, and then we run this a second time, and then we do these 3, and then we run this a third time, and then we do this 3. But because now 3 is going to be matching 3, we then reset out and we move north, and then we go back in. So hopefully that's clear. So that's what's happening there, and that's why we're planting bushes on each one. So it's going to look a little off now because we hit play in the middle rather than at the very beginning. So again, we could just reset it if we wanted to, and just go down to the bottom. So now you can see it's going to go 3 across, up to 3, up again, 3 across. And why does it reset to the left? Because it is attempting to move east again, but it can't, so it goes back to the beginning. Let's get rid of that one, by the way, just to clear the screen. So anyways, terrible explanation. Hopefully it makes sense, but you can see the inefficiencies already, right? We're no longer getting hay. We're only getting wood because of how simply this is being executed. But that's fine for now. So what next? So debug tools 50 and 50. We could get operators 150 and 10. So quite cheap on the wood. So let's do that. So operators basically means now we can add things together, plus, minus, etc. Not and or, comparison things. So we can say if this is equal to this, or if this is greater than this, and this is true as well. We can start to apply some more logic, basically. What else do we have, though? We also have X and Y, so senses. Now we can get a position, which is super important to know where the drone needs to know where it is. Alright, so now we can get its X position and its Y position, and then move accordingly. What else could we do? Can we do this? No, we need carrots for that. And we need 500 wood to improve the grass. We need 20 wood to improve the speed. So we can do the speed. And now we'll need carrots to get it more. And then to get carrots, we needed 50. And this requires till and plant. We'll get to that in a minute, though. Let's just focus on what we have now. And also, we want to expand again. Oh yeah, we need carrots to expand again. Okay. So our guy's doing his thing. Still continuing to loop this code, which is great. Let's just keep going to keep making wood anyway in the background. And we have a new code block. So I'll just move this over to the left. That's the running code. This is going to be our worker code. Or work in progress code, I should say. So ideally what we want to have happen is we get some grass, we get some wood, and eventually we get some carrots. That'd be nice. So we can do it in rows. So now that we know where we are on this little grid, we should be able to just like pop in a few statements and figure this out. So let's see. We also have the length of the grid as well now. So get world size. So get world size actually returns the size of the grid, at least along one side, I think. I think you have to type it out to see that syntax. So let's just see. Get world size. I guess you have to hover over to here. Okay, that's just my bad. Anyway, returns the side length of the grid in the north to south direction. So there you go. So that's it took me a while to figure that one out because I was like, oh, surely it's going to return 9. So I was trying to do math where I was dividing it by 3 or dividing it by itself to get like the length and stuff. Don't need to do that. It just tells you like from top to bottom how long things are. So anyways, now we don't have to set it to 3 manually. We can just say the range is now the length, or the max length of this grid. So that's fine. If it can harvest, then harvest. Plant bushes. We don't want to do that anymore. Now we want to say, let's go remove this a bit further down. So inside our for loop now, which is going to run for the length of the grid, we can basically say, I've never played a game where I have to type on screen. It's like actually weird because I feel like I type totally fine normally, but when there's like a camera on, it's like I can't seem to think or type or talk at the same time. Is probably the also difficult thing. Anyways, now we can say ELIF. So ELIF means else if. So if this isn't true, then run this one. So if your X position is equal to 1, right, it means you're in this group, then you could harvest, or we could say actually plant bushes. We'll harvest and then plant, really, is what you want to do. So we'll harvest and then we'll plant. And then we could say if you're, again, and you can actually separate these with lines. I keep forgetting that in normal. Yeah, I guess that's normally fine. All right, so anyway, if we're now at layer 2, then we can harvest and plant bushes again. And then we'll tell it to break out and move east. So you're moving to the right, depending on which one of these is true. And then you're moving north after you do the loop, which is the length of the grid, which is 3. So that should be fine. So let's pause that. We'll just clear the board and let's see if this is right. Nice. So we're now getting a little bit of grass and a little bit of wood, which is what I wanted to have happen. Awesome. Okay, let's have a look at what else we can do. We need to expand the grid by getting carrots, so let's unlock carrots. So carrots are annoying because you need to till the land first. So before you can plant carrots with the new plant entities.carrot, you have to till the soil. This will change the ground to ground's soil. To till the soil, simply call till. Calling till again will actually change it back into grassland. So you got to be careful of that. You can also see how much it costs to plant carrots. So unlike bushes or grass, which were free to plant, we now need to actually spend resources to plant a carrot. You need 1 hay and 1 wood. So that means we need a little bit of hay, we need a little bit of wood to equal the amount of carrots, at least currently. So let's work on it. So again, we'll copy this, paste it into our other block so that this is our running block and this could be our new function or code block. So nothing really needs to change here other than now that we're at, if we're at tile grid 2, which is the 3rd one over, we could harvest, plant, we need to till. But we know that if we till, it'll reset the 2nd time around. It'll turn it from grass back. So we'll just run that and just have a look at that little problem and then we'll get back to it. So let's say till, plant carrot, and then continue doing your thing. So we'll just pause it. Clear the grid, we'll just go back to the beginning and then we'll hit play. So now we expect carrots to be done here. Ah, we hit an error. Till. Till has never been defined. You must assign a value for it. What? Oh, I spelt it wrong. And we unlocked a new hat for being silly. Anyway, so there we go. So it's running now, and you can see that it put down carrots, puts down carrots. It'll put down carrots here, but now when it gets to this carrot, it's going to till the soil in reverse and not do what we wanted. So we need a sort of initializer, I think. So let's go and clear the ground. So we'll call this one initialize farm. Or we could call it, yeah, I guess init farm layout, right? So we're initializing the farm layout. So we can pretty much do what we had here for the most part. For now, I'm just trying to think, what did we unlock? We unlocked census, but we have not unlocked variables just yet. Okay, that's fine. So we'll just collapse this for now. Initialize farm layout. So while this is true, everything looks pretty good here, except we now need to say position 2, we want it to be tilde, but only if it hasn't been. So if grounds dot, so if it's soil, if it's grassland, then you can till it, yeah? So if get ground type is equal to grounds.grassland, then we till. Simple. And then afterwards we plant entities carrot, because if it already was tilled, you should just be able to plant after harvesting anyway. So that should be okay. Now, this is initializing the farm layout. It's supposed to be, but it will just keep running and actually be totally fine. But we'll modify this later to be an initializer, because we'll actually need that. Ah, I made a mistake. Again, forgot my parentheses here. Cool. So it works. Even though we started from an off angle, it looks like things are kind of moving in a weird way, but it's all right because we hard defined where it needs to be to do these things. So now we're making carrots, we're making wood still, we're making hay, everything's good. Life is good, no problems. Something else I'm going to do, just while we're letting things build up in the background, is we'll make a reset position call. So we want to move the drone to 0, 0. I don't think you can actually just straight up move it to a position, at least not yet. So what we'd have to do is, again, say while true. Alright, so I've got a little reset position function here. So if your X position is greater than 0, then move to the left. If your Y position is greater than 0, then move down. And if these are both equal to 0 at the same time, then break out of the loop. So break is a new command I didn't show, but basically means that you're just hard breaking out of the while loop. So it moves one increment out of a loop that's currently going on. So let's just see if that works. So we'll just pause this, and I'll say, I just want you to reset your position. It worked. Alright, cool. So we can leave that up here. So now when we want to reset things, we don't have to necessarily clear the entire farm, but we can just reset it. Alright, so we've made 97 carrots. We'll just, I suppose, leave this running. Why not? Again, I'll just get rid of that, and we'll get rid of this. These are old. We don't really care. This is our nice working initializer, which are actually just running anyway, because it works well. So the next thing that we need is variables. Assign values to variables. Or we could also expand the farm. Let's do that. Let's do both, really. So expand the farm, and then we'll unlock variables. So variables means that we can assign a value to some random thing that we hold, you know, a variable name. So a variable is just like anything. It's a piece of memory. And we say, like, this is called a variable. And we can name it anything we want. So we could call it Darren. And Darren could be false, Darren could be 1, it could be 10, it could be anything we want it to be. And then we can do things with it. So we'll get back to that in a moment. And the most important thing is we can do logic with it. We can divide it by other numbers, we can make multiple variables and divide them together, add them together, and that way we can track things a lot more cleverly. So, at the moment, things are okay. We've expanded our farm a little bit. In order to expand it again, we would need more carrots. Let's do it. 6 by 6. Now we need pumpkins. Pumpkins going to be a bit further down to get them. So we'll need to unlock trees, which we could also do right now, and water. But we'll wait to get to that. Let's see if we can make use of this farm. We've hard-coded a lot of what goes on in here. And so we're not actually really doing what we should be. Well, it's not bad, actually. I suppose because we did it by the X column, that we're just leaving these 3 because we didn't adjust those ones. So that's actually not too bad. Could be worse. But let's fix it. So, again, this is supposed to be just an initializer, but we just kind of ran with it. So now we could say we still need these have to equal each other. So we could do grass, grass, bush, bush, carrot, carrot. That might work. Again, these are kind of hard-coded values now, though. So if you're at 0, we could now say if you're at less than 2, you'll just place down grass, so that's fine. If you're at less than 4, yeah, so this is 0 and 1, 2 and 3, and then if you're at less than, well, really, it could just be else if. We don't even need to put in anything for this one. Let's try that. I haven't really tested this, clearly. So let's reset our position. Let's drive home. Got an error here. So why is there an error there? Do we need a condition for this else if, or can it just not just run on its own? It's not a valid expression. Oh, that's because we just need else. Sorry. So if this is true, if that's not true, then do this. If that's not true, just do this then, if neither of these are true. So yeah. And then we need a colon. Now this is pretty good, but what we haven't accounted for is that this has been tilled and we're not reversing it back. Not that we need to, the bush is growing it just fine, but I would like to make it grass again. So we could actually, in our initializer, say like, well, you should probably do a little check to see if the soil has been tilled where it shouldn't be and reset that. So let's just drive this back and then we could pop that in. So if ground type is... yeah, after the harvest. If the ground type is basically soil, then till it back. The same is going to be true for here. Ah, damn, I keep pressing Shift Tab, but it opens up a thing on Steam, doesn't it? So let me just copy that again. It opens up the Steam overlay. Shift Tab will be normally how to go back at a tab. There we go. I think that's right. So let's try this now. So let's see if it re-tills the soil and keeps everything else working. Seems good to me. So far, so good. Now, if we want this to be a true initializer, which I do, we can now say we just want to run this once. So once this is complete, then just stop running it. And that way we'll have reset our farm to the parameters that we want. Okay? Because at the moment, otherwise everything's been really hard-coded. I probably shouldn't have deleted the old function, actually, because it would have still worked regardless, but we'll write a new one. So, yeah, we want it to run just once, but we unlocked variables. So now we could say initializing, right? So that's just a made-up word for me. It could be anything. We'll say initializing equals true. So as soon as we go into here, we are now initializing. So instead of saying while true, we can say while initializing. So while initializing, do all this, and then when you're totally done, and how do we define that? Well, I guess we could say if your position is at 0, 0, which it will be when you reset yourself, then initializing will be false. So we just need a little check here. After moving north, I guess. If our position for our x is equal to 0, and our position for y is equal to 0. That means we're at 0, 0, and initializing is then going to be set to false, and that will break us out of this while loop. So let's see. Let's see if it just goes through this once. I'll tell you what, will be even more fun. We'll do a clear. So now let's see if we can initialize our farm layout as we intended. Now, I should also say that we could write code to, or comments to say what things are doing. So, you know, first two tiles grass. Next 2 tiles soil. I mean, it's obviously really easy to read anyway, but you know, you should comment your code. That's what people say. And then here we could say anything else. Make carrot. Or prep for carrot. So now we're saying the first 2 tiles are going to be grass, the next 2 tiles will be soil, and anything else after that will be carrot. How good is this? It makes you feel so good when it does it, when it works right. And it's always like, it's actually quite nice when it doesn't work, because it's really easy to find out why. And for people who do code, you know, you can actually put breakpoints down, you can track things, you can look over your variables and stuff. But let's see if this just runs once. That's also the other important caveat that I'm wondering about. So we're just about to hit the end. Boom. So it just stopped. That's exactly what we want. Because later on we'll do things... Well, I might not go too much further in the video, to be honest, but later in the game, things get quite complicated. So we can unlock trees now and just have a quick look at something. So trees are a better way to get wood than bushes. They give 5 wood each. Like bushes, they can be planted on grass or soil. Trees like to have some space, and planting them right next to each other will slow down their growth. The growing time is doubled for each tree that is on a tile directly north, south, east, or west of it. So if you plant trees on every tile, they'll take 2 by 2 by 2 by 2 by 2, which is 16 times longer to grow. And then for some reason they hid this, but the modulo operator, so the percentage operator, can be useful here. It returns the remainder of the division. Even numbers divided by 2 have a... even numbers divided by 2 have a remainder of 0, and odd numbers divided by 2 have a remainder of 1. So you can check if a number is even like this. So this is something I'm actually not familiar with. DEF, define, definition, is even n. Return n modulo 2. So I kind of get it. Like, I obviously generally get it, but I don't know necessarily what def is really there for. This returns true if n is even and false if it isn't. So if I wanted to learn more about that, you can look up operators. And in here we'll probably find stuff to do with like def or whatever. So there is like good documentation, I suppose, on how to learn certain things and like different functions and stuff. So I'll have to look into it. You know, I just haven't read it yet, or we might not have actually unlocked it yet. I feel like you unlock defines later, so it might be telling me a little bit early. Yeah, there it is. Define your own functions. So okay, so there you go. Do 2 flips, do a flip, do a flip, do 2 flips. I'm wondering if we'll be able to call other code blocks. But I suppose you could just write functions inside, which is fine then, I suppose. The other one then is water. So water the plants to make them grow faster. So use item water. So that's an interesting one. So plants grow faster when they're watered. The ground has a water level ranging from 0 to 1. Water level 0. The function getWater returns the water level of the ground it's over. The growth speed of a plant scales linearly from 1 speed at water level 0 to 5 speed at water level 1. The ground dries up over time. On average, it loses 1% of its current water per second, but there's some random variance to this. You can use water on your plants. 1 tank of water is automatically added to your inventory every 10 seconds. So yeah, we're getting some right now. A tank holds 0.25 water. So basically, yeah, that's interesting. That it only holds 0.25 water. Does that mean you need 4 tanks on 1 tile to give it full 100% water? I assume so. It ranges from 0 to 1. And then it scales its speed. Yeah. Cool. So I suppose maybe you could water your trees if you wanted them to grow fast, because they'll be spaced out and there'll be less of them, and that will give you a lot of wood. So you can see, just like even at the very basic level, things are getting quite complicated. No longer will this linear layout suffice. We'd have to start separating things out and counting what's in front of us and what's behind us, or because that's another thing you can do. You can say like, get the ground at this position but in the position next to me or behind me, and then you can kind of work out where your trees need to go. Or like it said, use a modulo, so you can always divide by see if you have a remainder after a division. I'm not very good at math though, although it's kind of doing it for you. The other thing I just wanted to run really quickly was another kind of copy of this, but one that isn't the initializer. So this is just going to be now our new main. And what this should be able to do is just understand what it's over. So for everything in the range, get X position. Yeah, we don't have to do that. We should just be telling it to harvest, no matter where it goes. I suppose not to be lazy, we could just write it out ourselves. So we'll start like this. So harvest, and then move east. And then move north. Is there anything else I need to do? Maybe. I don't know. Let's just run it though to see what happens. We don't need to say initializing. I guess we could just say while running. We could stop that on some weird condition if we really wanted to, but whatever. Ah. Yes, of course. So we need to actually plant the bushes again. I forgot about that. Yeah, I just got confused for a second. So if the entity type beneath us is a bush, then harvest it and then plant the bush again. So pretty straightforward. I was just thinking if we were to, because I wanted to put harvest like at the bottom just as one line of code, but we're going to have to use it multiple times. There's probably a better way to do it, but I don't know. I'm doing the best I can, to be honest. And it's like we're at baby level really here still. But anyway, yeah, if entity type then is equal to entities dot carrot. We don't want to till. We already have our initializer that set up the tilling of the land and everything, so that's totally fine for now. But we will say harvest again. And then we'll say plant entities dot carrot. And it's tempting to say like, well, we could use water on the carrot so that we just focus it on that instead. So use, is it items dot water? So now we're going to water our carrots, and then we could also just have a fallback. So else, if none of those things are true, so if it's not a bush, it's not a carrot, I can see a spelling error, then it's just going to be a harvest, because it's just going to be grass. And that should be okay, I think. We'll see how we get on with that. And then move east and so on and so forth. So we'll just reinitialize. So reset our position. Initialize. I suppose the initializer could have that reset in there, thinking about it. Now, just send that back to the bottom. Even better initializer would just look at the ones that aren't the way it should be and then go back. But we don't have full access to reading everything on the grid at the moment, I don't think. I think later you unlock a list, so you can actually store the entire array inside itself and then check it before you go to things. So that's what you do. Because this grid can get huge. Like eventually it's like 100 tiles or something, so you have to start really thinking about like where you send the drone to be like more optimal. Anyway, else. Let's try this now. Yeah, so we're throwing water on those. And you can see water level 0.23. Nice. Now, it's a waste though, isn't it? Because they're growing so fast, but I'm not getting to them fast enough. They're getting 100% before I ever get back down to them anyway. So there's really no need to use the water yet. Trees, I think, take a really long time, and that's probably what the water is really for. So let's, oh, I kind of messed that up, actually, because I paused it mid-thing. Let's remove the water in this instance. Yeah, what a shame. So I would have to use my initializer again. And fix that, and then go back. Interesting. Another thing here is, you know, it's checking what the entity is below it in order to know what to plant, but it's never going to plant on this because we didn't initialize fully. So I love stuff like that. It just shows my incompetence. But it's all, you know, all there to be optimized further. That's the fun of it. And there we go. So I think I'll leave it there, just as a general example of what this game is. I mean, I find it super addictive. So I've only gotten a little bit further where I made trees, and then I was just like, yeah, I think I'll do a video on this, even though it's really weird and kind of out there for my channel and everything. If people would like to see more and want to see me continue, let me know. You know, maybe I'll do it. I do feel like this will probably be a one-off, but you know, if the response is pretty good, maybe I'll just continue with it. I would like to continue with the game and try to get all the way to the end, because like I said, I'm relearning coding in a way, and I'm just trying to get my mind into that like logic flow state so I can solve these little problems and hopefully apply that in future. And it's kind of nice learning the different syntax as well. And trying to improve things. Something that I just have in my mind, which is like, I had all these, when I was playing, I had all these different code blocks, and I was like, oh, I wish I could really call them. You know, I want to call reset position inside of this. I don't know if that's possible. Maybe it happens later, or if not, maybe that's what the define is for. Define your own functions. So, I guess so. Maybe you just put it all into one big window. But that just, I felt like that's what the sub windows should be for. But I haven't looked through the tech tree, so I don't really know. But this, whatever this is, takes 100 million bones, it seems. Dinosaurs? Yeah, I don't know. It obviously gets crazy. It's funny, on the Steam page you can see like what a big map looks like and what people are doing. People are like have a huge board and they're like writing messages on it and doing crop signs and things like that. So it seems pretty funny like what you can do. Obviously, when you get a bit better at it. So yeah, that's pretty much going to be it for me. That's the farmer was replaced. So check it out on Steam. If you got any passive interest in incremental games, forget the coding aspect. I think this is one to check out. If you do like coding, obviously, or you want to get into it, I think it's a really nice, easy way to learn. It seems to be anyway. It's very chill. There's actually no music in the game except for the main menu, so it's kind of built for just like put on your own music and just play around. I'll probably have music in the video, but just so you know, it's not part of this game. Anyway, that's gonna be it for me. Thank you very much for watching. Please leave a like on the video if you're interested in it. Subscribe if you're new, and I'll see you in the next one.